Hey there, boys and girls. So today we're going to be talking about our recent patterning investigations, and I'm going to go over the different learning goals that we've reached so far to make sure that everyone's understanding what we've gone through. So the very first learning goal that we started talking about was how to create growing patterns using addition. Another word for that is arithmetic sequences. So aside from the AB patterns that you were first introduced to in kindergarten, arithmetic patterns are some of the simplest patterns around. They just require you to be able to skip count. So we can create a simple growing pattern with an equally simple pattern rule using addition. Start at 1 and add 3 each time to get the next term, and at 16. So our resulting pattern here would be 1, 4, 7, 10, 13, and 16. And you can see that we've added 3 to each of those, so basically we're skip counting by 3. We can also create more complicated patterns using addition, but by increasing by more than one value. So consider the following. If we start at 1 and alternate by adding 3 to get the next term, and then 4 to get the following term, ending at 16, this is what our resulting pattern would be. We would have 1, we would add 3 to get 4, we would add 4 to get 8, then we would go back to adding 3 to get 11, 4 to get 15, 3 to get our final value or final term of 18. Now our second learning goal, we wanted to be able to identify the pattern rule for growing multiplication patterns, or what are sometimes called geometric sequences. So geometric patterns involve a multiplicative relationship between terms. You must multiply each term by a factor to get the following terms. So a factor is just a fancy name for one of the two numbers in a multiplication expression that isn't the answer, that isn't the product. So for example, if you take term 1, the first term in your pattern, multiply it by 3, a factor of 3, you would get term 2 in this pattern that I'm referring to. Now to see that clearly, by thinking about factors, we can determine the pattern rule for multiplication patterns. So our pattern here is 1, 3, 9, 27, and 81. Based on this pattern, what factor do you think the numbers are being multiplied by? Look at the first two terms. What is the multiplicative relationship between these two terms? So 1 can be multiplied by 3 to get 3. So often the first two terms in our pattern, when it's a multiplication growing pattern, will give away what the factor is and what the rest of the terms will be multiplied by. So in this case, the pattern rule is start at 1 and multiply each term by 3 to get the next term, ending at 81. Okay, our third learning goal, we were learning to create shrinking patterns using both subtraction and division. And we were learning to put the pattern in a table with term number and term value. Now in these slides, I don't go through tables, but that is included when I talk about learning goal number 4. So that second part of this learning goal, I didn't go through here because most of us are really comfortable with that already, but I am going to go through both subtraction and division related shrinking patterns. Often shrinking patterns get way less attention, but we have done work with both subtraction and division. So let's look at some examples of shrinking patterns. In this instance, we can start at 100 and subtract 5 each time to get the next term, ending at 75. So we can use different strategies to subtract if we can't skip count. So not all of us are super comfortable skip counting, although it's a skill I encourage you to develop because it will help both your division and your multiplication. But you could manually subtract using standard algorithm or whatever strategy works for you. And that will still give you the pattern if you're using a pattern rule to determine the pattern. So in this case, our resulting pattern would be 100, 95, 90, 85, 80, and we end at 75. Now here's an example of a division pattern rule. So start at 400 and divide by 2 each time to get the next term, end at 25. So in this case, we can use halving, cutting the numbers in half, to figure out our pattern. It's basically the opposite of doubling. So in this case, our resulting pattern would be 400, 200, 100, 50, and 25. And you could use different division strategies to figure that out, or if you're comfortable doubling, then halving might already come pretty intuitively to you. All right, our fourth learning goal, we learned to represent a pattern found in a table using shapes. An important part of our pattern learning is being able to represent patterns using pictures and manipulatives. We can do this in many ways, so we're going to take a look at those now. So here's an example of a table, as I was talking about earlier. Now, putting numbers in a table is quite easy. On the left side, you always just have the term number. So whatever the numbers are in your pattern, they just get numbered 1 until the very last term. And then on the right side, the term value side, you would put the numbers that make up the pattern. So in this case, our pattern is 1, 4, 9, 16, 25, and 36. And we can try and figure out the pattern rule of the pattern in this table first, and that'll help us decide how best to represent this pattern. So a couple things to note with this pattern. In this pattern, it is a growing pattern, but it increases by different amounts each time. So in the first instance, going from term 1 to term 2, it increases by 3, then 5, all the way up to 11. And so there's sort of a pattern to that growth, because each time it grows by 2. So each time the amount you add to each term increases by 2. So here's an example of one solution. I went over this at the end of our lesson on this topic, and I like it because it's interesting and it's not as intuitive as some of the other responses. So we'll take a look at how we could use this to represent this pattern. So that solution works because it represents the rows, but when you move to term number 2, basically you're looking at rows 2 and 1. So for term number 1, it's just 1, and that's the single triangle on top. When we move down to term 2, it's 4, and we go from row 2 all the way up. So there are 4 triangles when you add rows 1 and 2 together. When we add rows 3, 2, and 1 together, we get 9, which is our third term, and so on and so forth. When we add rows 4 on up, we get 16. So as you add each row, the total of the triangles from the new row up to the top row represents the term value. So this is solution 2, and most of us came up with this solution or one very similar to it, where you took a shape and you made several rows or several groups of values, and each of those represented a different term. So term 1, the value of it is 1, so there's a single circle here. Term 2 is 4, so there are 4 circles, 9, 16, 25, and 36 for term 6. Now there's another way of representing this that's a little more elegant because it shows some different very interesting relationships with this pattern, and some of us chose to represent it this second way in class, which was very impressive. So here's what I'm calling solution 3. And in a second, I'm going to move to the next slide, and it'll show you exactly what the interesting relationship is. But maybe by looking at it, you can already see when it's set up this way what that relationship is. So if you take a look, obviously this one is just 1. So calling it 1 times 1 is a little bit silly until you realize that the rest of them follow that relationship. So if we group this into 2 rows and 2 columns, then it's 2 times 2. This one we group into 3 rows and 3 columns, 3 times 3, and all the way up to 6 times 6. So now we've made a new discovery, and we can kind of add that to our table here to help us make sense of our pattern. So term 1, the value is 1, and in brackets we have that multiplicative relationship of 1 times 1. The second term is 4, and that's 2 times 2, 3 times 3, all the way up to 6 times 6 for 36. All right, thank you so much for watching this video. I hope you learned a little bit more about fractions, or maybe it just helped you to solidify or cement some things you had learned but maybe weren't 100% sure of. I encourage you to comment below if you have questions, or if you have ideas for other things that you want to learn through these videos, maybe other skills that you want to develop. So feel free to comment below and let me know what type of content you want me to create. All right, happy mathing.